Hello, it's Malcolm here, and in this screencast we're going to talk about how mathematics is developed. And this topic, like all the topics that we've studied in this course really, is not meant to relate directly to what you will be doing in the classroom as a teacher. Rather, it is aimed at broadening your view of what mathematics is and how mathematics is done. And I'm hoping that if you are exposed to these ideas, it will make you think about your role as the teacher of mathematics to subsequent generations. And it may, or may not, lead you to think about what it is that you would actually like to teach about mathematics in your classroom. I suspect for most of you, as you sat as a student in your maths classrooms, that you didn't stop to think about where the mathematics that you were learning actually came from. However, we've done enough in this course now that we can actually talk about where the maths comes from. As we have seen, as mathematicians work, they often problem pose as well as problem solve. We problem pose, for example, in every time we make a conjecture. There's a question, is it true? We problem pose when we review at the finish. Say, where can this method take us? What other questions can we actually solve in a similar method? What other questions are related to the one I just solved? And these questions quite often haven't been asked before, and so investigation of those problems constitutes doing new mathematics. We haven't talked about this yet, but we're going to. Mathematics is often applied to situations and contexts that are outside the discipline of mathematics. And when it is, if that situation is a new situation or a new context, then you are again doing new mathematics. So we'll practice that a bit later on. The interesting thing here, of course, is that the time frame over which this new mathematics comes into being. Depending on the difficulty of the problem, sometimes the person who poses the problem only gets a little way into the investigation. Then somebody else might take up the investigation later on if they're interested, and they might have to invent new methods or new ideas onto the problem. They might even bring methods from other parts of mathematics. Sometimes the progress is very slow, and it might take 10, 20 years, even hundreds of years, for the ideas to become sorted and to become, if you like, well understood. And what happens is eventually it becomes well understood, and then it becomes, what is it? They summarise it and make it succinct, and eventually it might even make its way into your school textbook, where you learn how to use the method and do a series of exercises on it. Of course, as you are doing the exercises, you don't see, or you don't think about, all of those hundreds of years spent developing the idea to the level that you're actually using it in your textbook. So, the thing is in here, we've said as mathematicians work, they problem pose and so on. That's exactly what we're doing here as we're learning to think and work mathematically. The only difference between the development of new mathematics and what we're doing in this course is that the things that we do here are probably not new to the whole maths community. They're probably only new to us. So in a way, we're developing our own mathematics here. So, once a mathematician has done what they think is an interesting investigation, how can they decide if their work is indeed new, and if it is new, is it correct? Usually the mathematician themselves would be confident that it's new and it's correct, but they can't be certain. And so they would do things like, they would search, these days it's pretty easy with the internet, to see if anyone else has solved this or similar problems. Quite often though, they will also talk to their colleagues, either directly, perhaps in the workplace, but via conferences, via seminars, via blogs, and so forth, to see if anyone else has done work or similar work. And finally, if they decide that, yes, I think this work is new, then they will put their work up for public scrutiny. And usually, they will do this via an academic journal. The reason that academic journals are used is because there's a process associated with publishing an academic journal, and that is considered the best process to legitimise your work. And so with a paper submitted to a journal, the journal then usually sends the paper to some referees, and referees are people deemed to be acknowledged experts in the field and with enough knowledge to be able to actually read and understand the work. And so the referee will then judge the worth of the work. They'll say, yes, this is a very important piece of work, it needs to be published. They will say, yes, I believe this work is correct. And then they'll say, yes, the style of the paper is such that our readership could understand it. Now, quite often, a paper doesn't get through on its first submission. In fact, very rarely does a paper get through on its first submission. The referees will comment on all these different aspects, make suggestions for improvements and so forth. And so the author will go through and do a number of resubmissions, and eventually the paper will get published. And once it's published, anybody who wants to can then read it. And if over time no one claims that the work has any deficiencies, then it's deemed to be correct. And I should say, of course, that quite often papers are published that actually do contain minor errors. Some of them even contain major errors. But if the work is important, other people will eventually find these and correct them. And so you can see by putting your work through a journal, it has a thorough vetting process, if you like. There is a bit of a trend these days to put work up on a blog, for example, but with a blog, the paper hasn't been vetted in any way, and so therefore you have to be far more sceptical when you read it. I've said here that the referees judge the worth of a work. That's, I guess, true, they do that, and that's somewhat subjective, but the real worth of a work is determined over time. If the work turns out to influence the work of a whole lot of other people, or if it turns out to be useful in a whole lot of different contexts and so on, that really determines whether a piece of work was worthy. There are lots and lots of academic papers that are published that nobody has ever read and that has never influenced anything else, and so just sit there. And so, are they worthy? Well, it's still hard to tell, because quite often in mathematics an idea is thought up and developed, and then it's not used, say, for another 50 or 100 years. So you can't envisage whether this is going to be good or not. But anyway, so time is really the final judge on the worth of a piece of work. So out of all of this, you can see that the idea of communication of mathematics, both in terms of explaining your ideas to others and in giving feedback to others, it's an essential part of the whole process of developing the discipline of mathematics. Quite often you hear a student say, I did mathematics because I don't have to write. Well, that might be true in your school level courses, but if you're going to be a working mathematician, then communication is really important. You will have to write convincing arguments. You will have to explain your work to others in presentations and talks. You'll have to comment and review on the works of others, and so on. And so communication really is a vital part of the discipline of mathematics.